Okay, today we're going to try to look at some triangle segments. And some of this you may have seen before in math too. Some of this may be new. I'm going to show you this using Desmos geometry. You might want to follow along. So I'm going to show you how to get this program. And then that way, if you want to try it yourself using this program, it's pretty easy to use. And there's a lot of neat geometry stuff you can do there. We're going to go to Desmos geometry. I'm just searching for it in Google. And it should be the first thing that pops up. It's just a geometry version of the Desmos calculator we've been using a lot in class. So what we are going to have is it gives us some options over here. We can see, let me see if I can get the cursor to show up a little bit bigger, but it's going to go over here and we are going to want a polygon. So pick the polygon option here. And then the polygon, I'm just going to click and I want a triangle. So I'm going to do 1 point, a second point, a third point, and then since I only want 3 points, go back to your first point and click on it. That lets you know the polygon's done. You could, of course, make as many points as you want, and you'll know the polygon's done when you click on your starting point. So once I have this triangle, I'm going to need the median of a triangle. Now, the median of a triangle is the line that goes from a vertex to a midpoint. So to be able to get the median of a triangle, what I'm going to need to do is go to More Tools, and I want to find the midpoint. So I'm going to click the midpoint of this side, and under More Tools, I'm going to pick midpoint once again. The midpoint of this side, I'm just clicking the side that I want the midpoint of. And since it's already on midpoint, I can click this and I have the midpoint of each side. You notice that each of these dots I've just created is the midpoint or the point in the middle of that side of the triangle. So those are the midpoints of the sides of the triangle. Now, when we're talking about a median line, I'm going to show you a median line. I'm going to pick the tool segment here, and I'm just going to make a segment that goes from this point here to this point here. And once again, I'm just clicking on the points to select them. That's the median of the triangle. Now, one thing you will notice about the median of the triangle is that if I folded the triangle along its median, the triangle would kind of fold in half along that median line. It wouldn't necessarily be symmetric along the median line, but half the area is on one side of the median line and half the area is on the other side of the median line. Now what I can do is I can go and find a median for each of my sides. I'm going to go ahead and find the median for this side here. So the median for that side there, I go from the midpoint to the opposite vertex. And you're like, how do I know which vertex to pick? Well, if you try to pick the wrong one, you can kind of tell that's not going to be a new line at all unless you find the one that's straight across from that side. So that's going to be another median. And then the last thing I'm going to have to do is I'm going to have to pick the last median line, this point to this point. And each of these medians kind of go right through the middle of the triangle. They don't necessarily divide it into symmetric or congruent figures or symmetric figures, but they do split the area of the triangle in half. Now, what we will notice is when we draw these medians, all three of them intersect in a single point. So I'm going to go ahead and mark a point, and I'm going to choose to label that point, if I can remember how to do this. I'm going to give it a label, and the label I'm going to give that special point there is I'm going to call it the centroid. And this centroid is just the point that is in the center of the triangle. Now, one thing you can think about the centroid is if I cut this triangle out of a piece of plywood or something, and I wanted to balance it on top of a rod or a dowel or something like that, even my finger, if it was a small enough piece of wood, if I had something sturdy that I made the triangle out of, it would balance right on that centroid. So if you tried to, you could put it, you could put a rod or a tip of a screwdriver or something like that right at the centroid, and that triangle would balance perfectly on that centroid point. It's pretty much in science class, you might have talked about a center of mass. The centroid is the center of mass of the triangle because it's in the exact middle of all the triangle's area. So that's one thing that's important about the centroid. But probably what's more important about the centroid is, for our purposes, is some problems we can do. So just know that the centroid is the place where the medians intersect, and I'm going to show you a couple examples of problems we can do based on the centroid. Let's go ahead and should have a pen here I can write with. Let's just call this triangle ABC for the point of having something to do, and we'll call the medians D, E, and F, and we'll call the centroid point G. right there in the middle. So one thing I can do is I can say this centroid splits these median lines in a 2:3 ratio. So the centroid will split the median in a 2:1 ratio. And I might have said 2:3 the first time. The truth is the whole thing is 3. So the long side is 2, the short side is 1, and the whole thing is 3. I'll show you what I mean by that. If I know that this side is 4, this side is going to be half as much 2, and then the whole thing is 6. So I have a 4:2 ratio, which I could divide by 2, and it would reduce to a 2:1 ratio. That works anything. So that's one thing you can do. If they give you the long piece, you can figure out, oh, the long piece is 4, so the short piece has to be 2. Let me go ahead and show you another one on the same triangle. If I called this piece here, let's say this time they give you the short piece, and they say this short piece is 3. If the short piece is 3, then the long piece, since it's a 2:1 ratio, has to be twice as long. It would have to be 6. Because you have to have the long piece twice as long as the short piece. Now, some students have said, Mr. House, how do I know which piece is the short piece and which piece is the long piece? Well, if you will notice, whenever it's drawn to scale, the long piece is the one that has to stretch all the way into the corner. So I kind of think of it as if you're trying to get a pair of shoes out of your closet and it's kind of falling all the way back in the corner. You have to reach further to get all the way into that corner than you would to get to the wall. So that's you're just going straight back to the wall. It's a little ways back, but it's not nearly as far as this distance here, which where you're going all the way to the corner. So the longer piece, the piece that's twice as long as the piece that goes all the way to the corner. Let me go ahead and erase what I have here, and we will do a couple